In the vast expanse of our solar system, far beyond the familiar glow of the inner planets, lies a world of icy mystery, Uranus. It was discovered in 1781 by the astronomer William Herschel. He initially mistook it for a star. However, its movement across the sky soon revealed its true nature as a planet. This discovery expanded the boundaries of our known solar system. It ignited a thirst for knowledge about this distant and enigmatic world. Uranus is the seventh planet from the Sun. It lies at a staggering distance of about 1.8 billion miles. This distance makes it invisible to the naked eye. Even with telescopes, Uranus appears as a small, faint disk. However, beneath its seemingly bland exterior lies a fascinating world of unique characteristics and intriguing mysteries. The discovery of Uranus marked a pivotal moment in our understanding of the cosmos. It challenged the long-held notion of a solar system limited to the 6 planets known since antiquity. This discovery opened our eyes to the possibility of other, yet undiscovered worlds. It spurred astronomers to peer deeper into the cosmos. Uranus stands out among the planets in our solar system due to its extreme axial tilt. Imagine a planet tipped over on its side, and you have Uranus. This unusual orientation is a defining characteristic of this ice giant. It sets it apart from its celestial neighbors. While most planets spin like tops, with their axis of rotation roughly perpendicular to their orbital plane, Uranus spins like a rolling ball. Its axis of rotation is tilted at an angle of approximately 98 degrees. This means that Uranus's north and south poles are located where most planets have their equators. This extreme tilt has profound effects on Uranus's seasons. Each pole experiences 42 Earth years of continuous sunlight, followed by 42 years of darkness. Imagine living on a planet where a single season lasts for decades. This unusual seasonal cycle creates extreme temperature variations across the planet. It influences its atmospheric circulation patterns. Gazing at Uranus through a telescope, one is greeted by a serene pale blue-green orb. This ethereal hue is a product of the planet's unique atmospheric composition. It reflects the sunlight that has interacted with the gases in its upper layers. Uranus's atmosphere is primarily composed of hydrogen and helium. These light gases dominate the atmospheres of many giant planets. However, it is the presence of a small amount of methane that gives Uranus its distinctive color. Methane absorbs red light from the sun. It reflects blue and green light back into space. While visually stunning, Uranus's atmosphere is also incredibly cold. Temperatures in the upper atmosphere can plummet to a frigid -371 degrees Fahrenheit, or -224 degrees Celsius. This makes Uranus the coldest planetary atmosphere in our solar system. These extreme temperatures are a consequence of Uranus's vast distance from the Sun. They are also due to the planet's internal heat, which is unusually low compared to other giant planets. Beneath Uranus's frigid atmosphere lies a mysterious interior. Scientists believe that this interior holds clues to the planet's formation and evolution. While we cannot directly observe this hidden realm, scientists have used a variety of techniques to study it. These techniques include analyzing Uranus's gravitational field and studying its magnetic field. Uranus is classified as an ice giant. This means that it is not a gas giant like Jupiter or Saturn. Instead, a significant portion of its mass is made up of ices. These ices are not just water ice. They also include ices of methane, ammonia, and other compounds. These ices exist in a supercritical fluid state. This means that they have properties of both liquids and gases. Scientists believe that Uranus may have a small rocky core. This core is surrounded by a vast mantle of icy materials. This mantle is not a solid frozen layer. Instead, it is thought to be more like a hot, dense fluid. This fluid is constantly churning and flowing. This creates the planet's magnetic field. Section 5. Faint rings of ice and dust. Uranus, like its more famous ringed neighbor Saturn, is adorned with a system of rings. These rings, however, are far more subtle and elusive than Saturn's majestic rings. They were not even discovered until 1977. They require powerful telescopes to be observed from Earth. Uranus's rings are composed of countless icy particles. These particles range in size from tiny dust grains to small boulders. They are thought to be the remnants of comets, asteroids, or shattered moons. These objects were torn apart by Uranus's gravity. 13 distinct rings have been identified around Uranus. Each ring is named after a letter of the Greek alphabet. These rings are very dark and narrow. This makes them difficult to see. They are also much fainter than Saturn's rings. This is because the particles in Uranus's rings are less reflective. They are also more widely spaced. Section 6. Miranda. A moon of extremes. Uranus is orbited by a retinue of 27 known moons. Each moon is a world unto itself. These moons are named after characters from the works of William Shakespeare and Alexander Pope. These moons exhibit a fascinating diversity of geological features and orbital characteristics. Among Uranus's moons, Miranda stands out as a particularly intriguing object. This small moon is a testament to the chaotic and violent forces that have shaped our solar system. Miranda is unique for its incredibly diverse and jumbled surface. This surface features towering cliffs, deep canyons, and strange grooved terrain. Miranda's surface is thought to be a patchwork of different geological terrains. These terrains have been broken apart and reassembled by past impacts. Some scientists believe that Miranda may have been shattered into pieces by a massive collision early in its history. These pieces then reassembled under their own gravity, creating the moon's chaotic appearance. Section 7. A magnetic mystery. Uranus's magnetic field is yet another aspect of this ice giant that sets it apart from its planetary siblings. Unlike Earth's magnetic field, which is generated by the planet's molten iron core, Uranus's magnetic field is generated by the movement of electrically conductive fluids. These fluids are located in its icy mantle. Uranus's magnetic field is also unusual in its orientation. It is tilted at a dramatic angle relative to the planet's axis of rotation. This tilt is about 59 degrees. This misalignment is unique among the planets in our solar system. It suggests that Uranus's magnetic field is generated by a complex and dynamic process. The unusual tilt and offset of Uranus's magnetic field have profound effects on the planet's magnetosphere. This is the region of space dominated by the planet's magnetic field. This magnetosphere is constantly being bombarded by the solar wind. This is a stream of charged particles emanating from the Sun. The interaction between Uranus's magnetosphere and the solar wind creates auroras. These auroras are similar to the northern lights on Earth. However, they are much fainter and more difficult to observe. Section 8. Voyager 2's encounter with Uranus. Our most detailed glimpse of Uranus came from NASA's Voyager 2 spacecraft. This intrepid robotic explorer flew past Uranus in January 1986. This was a fleeting encounter. However, it provided a wealth of scientific data and stunning images. These continue to shape our understanding of this distant world. Voyager 2's flyby of Uranus was a remarkable feat of engineering and scientific exploration. The spacecraft had to travel for over 8 years and cover billions of miles to reach its target. During its encounter with Uranus, Voyager 2 made numerous groundbreaking discoveries. These discoveries included the discovery of 2 new rings, 10 new moons, and the confirmation of Uranus's unusual magnetic field. Voyager 2's observations of Uranus's atmosphere revealed a surprisingly bland and inactive world at visible wavelengths. However, the spacecraft's instruments detected traces of hydrocarbons and other complex molecules in the planet's upper atmosphere. These discoveries hinted at a more complex and dynamic atmosphere than initially met the eye. Section 9. Unlocking the secrets of an ice giant. Despite the wealth of knowledge gained from Voyager 2's flyby, Uranus remains a world shrouded in mystery. Many fundamental questions about this ice giant remain unanswered. How did Uranus acquire its extreme axial tilt? What is the precise composition of its icy mantle? What is the nature of its internal heat source? These are just a few of the questions that continue to intrigue planetary scientists. To answer these questions, a dedicated mission to Uranus is needed. Such a mission would allow us to study Uranus's atmosphere, rings, moons, and magnetic field in unprecedented detail. This would provide invaluable insights into the formation, evolution, and dynamics of ice giants. Uranus is a compelling target for future exploration. Not only does it hold clues to our own solar system's history, but it also serves as a prototype for understanding the countless ice giants that are thought to populate our galaxy. By unraveling the mysteries of Uranus, we can gain a deeper understanding of the diversity and evolution of planetary systems throughout the cosmos.